This is video 2 for the Psych 642 repeated measures ANOVA assignment. So since we have looked at the data set and looked at the descriptive statistics and tested for normality, we're going to move to the next step of setting up the repeated measures analysis. Before running the analysis, I do have to set up the planned contrasts. So I can't remember if I mentioned in the last video what the specific hypotheses were, so I'm going to go ahead and mention those now and explain how they relate to the planned contrast. The specific hypotheses were that depression scores would be less in the exercise groups compared to the control group, as well as that there would be a difference between the 30-minute group and the 15-minute group. So in order to test this, I'm going to set up orthogonal contrasts, and to do that, I'm going to set them up as variables to start with. So control versus exercises first, and you can see I've done the orthogonal contrast there, where the control is 2 and then -1, -1 for each of the exercise groups. So I'm going to create that. And then the 15 versus 30 contrast, once again, set up with 0 since the control is no longer in this comparison. -1 and 1. Then I'm going to actually set these two newly created variables as the contrast for the exercise variable, which I'm doing with the cbind function for the depression data. The exercise variable located in the depression data set. So I'm going to run that. So that sets up the contrast. And then I can just execute this line of code to bring up and make sure that the contrasts were set properly. It'll show me the information on the exercise variable. And you can see here that the contrasts were set up properly as they were written in up here, based on the output down here. So now that the contrasts are set, I can run the actual analysis. So there are two options to do a repeated measures ANOVA. The first is the easy ANOVA function, which provides an output with sum of squares and an output that you think of whenever you think ANOVA. It also tests for sphericity and does a correction if the sphericity test is significant. However, I'm specifically interested in planned contrasts, and I've set up those hypotheses. And based on everything that I've found both in the book and online, you can't do planned contrasts with the model that you create using the easy ANOVA function. So instead, I'm going to do the second option, which is the LME function. The LME function actually sets the analysis up as a regression model. Specifically, it is a multi-level model, and it handles the dependent data in the repeated measures analysis by explicitly modeling the dependency. So the dependency that we get from using the same participants in each group gets actually placed into the model that we create. It's specified in there. So taking a look at the LME function here, we still are going to specify our outcome variable and our predictor variable, but we're also going to add in this random term, and this is the part of the model that specifies the dependency. So you can see here that this specific part of the code tells the model that data from the same participant with different levels of exercise are dependent. And then it goes on to just specify the data and the method. So I'm going to go ahead and run this to create this model. And we'll see in just a minute, a little bit later, that if you take a summary of this, it'll give you the information for the plane contrasts. However, in order to get the overall effects of exercise on depression scores, then we'll have to create a baseline model that does not have the predictor exercise in it and compare the two. So that's what this next line does. It uses the LME function to create that baseline model, and you can see it still has the same outcome variable, but a 1 is put in here to represent the intercept. So there's no extra predictor in here. So we'll be able to compare the exercise model to just this basic model. So I'm going to go ahead and run the baseline model. And then we'll use the ANOVA function to compare the two. So that's the next step. And then whenever I run that, you can see that there is a very significant p-value here. And then, like I mentioned before, I'm just going to run the summary function with exercise model to give the planned contrast that I set up. So we could see that no exercise compared with exercise, there is a significant difference in depression scores, but there is not a significant difference in depression scores between the 15 minutes of exercise and 30 minutes of exercise. So now that we have our results of our repeated measures, the last thing we need to do is calculate the effect size. So as I did in one or two of the previous assignments, I'll be creating a function called R contrast that calculates the effect size R from the t-value and the degrees of freedom given right here in the plane contrast. So I'm going to go ahead and run this to create that function. Okay, and then I'm going to run the R contrast function twice, once for each of the planned contrasts. So you can see that the t-value from the first planned contrast is in there, as well as the degrees of freedom. And then in this one, the second t-value and the degrees of freedom. So we get both of our effect sizes for the plane contrasts. Now, the one thing that you may be thinking is missing from this analysis is looking at sphericity and testing that assumption. When using the LME function, it's not necessary to test for sphericity because using these regression models to test this hypothesis and to do the repeated measures analysis, we are already factoring in that the dependency is there by including this random aspect of the code. So it's already specifically in the model that the dependency is there. So testing for sphericity is not, and testing and correcting for sphericity is not necessary when going about this method. So it's robust and it does not need it. It doesn't run it, and that's why it's not here. Alright, so now to recap and end the videos for this assignment, I'm just going to show where I'm pulling information for the summary of findings out of the output that we just got. So you can see that the information for the overall effects here are coming from the results of this ANOVA function that compared the two regression models, the baseline and the exercise models. So the chi-squared is coming from the L ratio, which is right here, the 93.67. The p-value is right here. And then the difference in the degrees of freedom is what goes right here. You can see the difference between 6 and 4 is 2, which goes in right there. The mean and standard deviation for each of the groups is found in the stat.desc output. So you have the mean for each one here, as well as the standard deviations. Then looking at the planned contrast, that information comes from the results of the summary of the exercise model. You can see here that the B values are taken from right here. The T values are taken from right here. The degrees of freedom from here. And then your P values from right here. The R's were calculated using the R contrast function. You can see that the first effect size is taken from here, the 0.96, and then the second is taken from here, the 0.30. So that concludes the breakdown of the repeated measures analysis using the LME function to complete this analysis, and a visual representation of where the information from the summary of findings is coming from out of the output.